Chapter 1. The Vision. Why the world needed Webb. In the vast silence of space, something was missing. Humanity had questions, not small ones, but the kind that keep you up at night. Where did we come from? Are we alone? How far back can we see in time? For decades, the Hubble Space Telescope gave us glimpses, beautiful, groundbreaking, but even Hubble had limits. It was like trying to study the ocean with a pair of binoculars. We needed something deeper, sharper, and more powerful. And that's when the dream of the James Webb Space Telescope was born, not just as a tool, but as a cosmic time machine. Webb wasn't created overnight. This was a vision, decades in the making, a collaboration between NASA, the European Space Agency ESA, and the Canadian Space Agency CSA. Some of the brightest minds on Earth came together for one bold purpose: to build a telescope that could look back 13.6 billion years into the past, to the very edge of the observable universe, and show us the light from the first galaxies ever born. But this wasn't just about science, it was about humanity's hunger for knowledge. We live on a tiny rock spinning in a vast, dark sea, and every now and then, someone dares to build a ship to sail further than we've ever gone. The James Webb Telescope became that ship, an instrument of wonder designed not only to observe, but to inspire. The world didn't need another satellite, we needed a vision. Something that could pierce the darkness, something that could stare into infinity and bring back answers, or even better, more questions. And that's exactly what Webb was meant to do. Now let's keep it 100, this wasn't cheap or easy. Over $10 billion was poured into this project. Critics called it risky, overblown, even doomed. It was delayed, re-engineered, nearly cancelled, but like all great visions, it survived. It was fueled by the same spirit that put footprints on the moon and rovers on Mars, the belief that impossible just means not yet. So why did the world need Webb? Because every generation deserves to see a little bit further. Because the stars still call out to us, and because someone had to build the next eye to watch the universe unfold. And now, that eye is wide open, watching, listening, telling us stories written in starlight. Chapter 2. Building the Beast. Engineering a modern marvel. If the James Webb Space Telescope was a dream, then building it was the ultimate test of faith, patience, and human genius. We're talking about a machine so complex, it had 344 potential single points of failure. That means one wrong move during launch or deployment, and the whole mission would be toast. But they still did it. Why? Because greatness don't come easy. And this telescope, this ain't your average eye in the sky. This is the LeBron James of space instruments. Precision, power, and purpose, all wrapped into one gold-plated masterpiece. The mirror that sees through time. At the heart of Webb is a massive 6.5-meter, gold-coated mirror, the largest mirror ever launched into space. Unlike Hubble's single-glass mirror, Webb's is made of 18 hexagonal segments, each polished to atomic-level precision. And they're not just shiny for style, they're coated in pure gold because gold reflects infrared light better than any other metal. And infrared is Webb's specialty. Why infrared? Because light from the earliest galaxies is redshifted, stretched out as the universe expands. To see those ancient signals, Webb had to be built as an infrared beast. That's why its mirror isn't just large, it's legendary, the coolest shield in the universe. Now picture this: that mirror and all its instruments are sensitive to heat, like super sensitive. So they had to be kept colder than deep space, around -370 degrees Fahrenheit. To do that, Webb carries a 5-layer sunshield the size of a tennis court, each layer thinner than a human hair, made of a high-tech material called Kapton, and coated in aluminum and silicon for thermal protection. This shield blocks out the heat from the sun, Earth, and even the moon. Without it, the telescope would overheat and go blind. With it, it becomes an icy sniper locked in on distant galaxies. The space origami deployment, here's where it gets wild. Because the telescope is so big, it couldn't launch in its final form. It had to fold up like some high-tech origami puzzle. After liftoff, Webb went through over 50 major deployment steps, unfolding its sunshield, extending its mirror wings, adjusting tiny motors to align the segments down to nanometers. Every movement had to be flawless, no second chances. No mechanic in space to fix a jammed latch. The whole world held its breath for weeks as Webb slowly, methodically came to life in the cold void of space. Teamwork across the planet. Behind all this was a global village of scientists, engineers, and visionaries, thousands from 14 countries and over 29 US states. It took over 20 years to design, build, and test Webb. It survived technical issues, political heat, and budget wars, but that passion never died, because they weren't just building a machine, they were building legacy. What they created wasn't just a telescope, it was a monument to human willpower, a symbol of what we can do when we reach past fear, past failure, and aim straight for the stars. This is the beast they built. And it's up there now, floating in silence, collecting light from the dawn of time. Chapter 3. The launch heard round the world. It was December 25, 2021, and while the world was unwrapping gifts and chillin' with family, a different kind of present was being delivered, not just to one person or nation, but to all of humanity. The James Webb Space Telescope sat locked inside an Ariane 5 rocket, fueled up, folded tight, and ready to make history. No sleigh, no reindeer, just 7 tons of precision-packed tech aimed at the stars. But don't get it twisted, this wasn't just another rocket launch. This was the most ambitious space deployment ever attempted. And the pressure, astronomical. The world was watching, billions of dollars, 2 decades of sweat, setbacks, and sacrifice. And only one shot to get it right. There were no do-overs. If something went wrong during launch, the whole mission could have been lost before it even left Earth. People across the globe tuned in, scientists, students, stargazers, and even folks who don't usually follow space stuff. Because this was more than science. This was hope wrapped in technology, a rare moment when the whole planet held its breath together. Then, 7:20 a.m. EST rolled around, engines ignited. Smoke and fire exploded beneath the Ariane 5, and just like that, Webb was on its way, smooth like silk. From the moment that rocket cleared the pad in French Guiana, everything was butter smooth. No last-minute glitches, no dramatic aborts. It was one of the cleanest launches in history. Within minutes, the upper stage separated and gave Webb the final push out of Earth's gravity well. But here's where it got real interesting. Instead of heading into orbit like Hubble, Webb was aimed at a destination 1 million miles away, the second Lagrange point, or L2. That's a gravitational sweet spot where the telescope can stay in perfect balance with Earth and the Sun. It's cold, it's dark, and it's perfect for deep space observation. Over the next 30 days, Webb coasted through space on the ultimate road trip, deploying piece by piece like a high-stakes ballet. The sun shield unfurled, the mirror arms swung into place, tiny motors aligned all 18 segments into a single, flawless surface. Every single move worked flawlessly, one after another, against the odds. A launch for the ages. You could feel that shift in the air, like we had just stepped through a new door as a species. From dusty cave walls to golden mirrors in deep space, Webb's launch was a milestone moment, not just for science, but for the human spirit. And now, that telescope's been gliding quietly ever since, in total silence, in total precision, watching the light of ancient stars pour in. Webb is built to detect infrared light, which is basically heat. So while Hubble gave us stunning shots of stars and nebulae, Webb reveals what's hidden behind clouds of dust, like the birthplaces of stars, the atmospheres of distant planets, and the echoes of the first galaxies ever formed. Instruments that work like magic. Webb ain't rollin' solo. It's strapped with 4 high-powered instruments, each with a specific job. NIRCam, near-infrared camera. This is the main eye, capturing those crystal-clear deep-field images. It can spot the faintest galaxies ever seen. MIRI, mid-infrared instrument, goes even deeper into the infrared zone, perfect for cold objects like forming planets and dust clouds. NIRSPEC, near-infrared spectrograph, breaks light into its ingredients to analyze chemical compositions. Think water, carbon, oxygen, even methane in alien atmospheres. FGS, nearest fine guidance sensor, near-infrared imager and slitless spectrograph, helps keep Webb locked onto its target like a sniper, while also helping with exoplanet detection. Each one of these is like a specialized sense. Together, they turn Webb into a full-on cosmic detective. It sees with precision beyond human understanding. Here's the wild part. Webb can see details the human eye could never comprehend. It's so sensitive, it could detect the heat signature of a bumblebee on the moon from Earth. It's like putting a stethoscope to the heart of the universe and hearing it beat. And because it's at the L2 point, far from Earth's heat and light pollution, Webb stays icy cold, protected by that 5-layer sunshield, giving it a clear, uninterrupted view of deep space, staring into forever. With each new image, Webb shows us not just what the universe looks like, but what it was like billions of years ago. We're not just looking at stars. We're looking at ancient history frozen in light. We're watching the first sparks of creation replay in real time. That's the power of Webb's vision. It's not just about cool pictures. It's about rewriting our understanding of where we came from, what's out there, and how mind-blowingly vast reality truly is. Chapter 5. First Light. What has Webb already discovered? When the James Webb Space Telescope sent back its first images, the universe cried tears of light. The world stopped scrolling for a second. Even the most skeptical scientists had to sit down, look at those glowing galaxies, and say, "This changes everything." That first drop wasn't just a flex, it was a statement. The future of space exploration has officially begun. The deep field that broke the internet. NASA dropped the first full-color image on July 11, 2022, and let's just say, it shattered expectations. The image was a deep field shot, showing a patch of sky about the size of a grain of sand held at arm's length, yet it revealed thousands of galaxies. Not stars, galaxies, some of them so old, they were shining when the universe was just a few 100 million years old. Light that's been traveling over 13 billion years, captured in one photo. That image hit the timeline like a mixtape that changed the game overnight. Galaxies, like you've never seen them. Webb started pulling in spiral galaxies, elliptical galaxies, even galaxies merging and colliding in real time. Some of these structures are so ancient, they've never been observed before. Scientists found entire clusters that challenge what we thought we knew about how fast galaxies form in the early universe. Webb's showing us that the early cosmos was way more active and way more complex than we imagined. The Carina Nebula, a star nursery in 4K. Then Webb turned its golden gaze to the Carina Nebula, a giant cloud of dust and gas where new stars are born. What it revealed? A cosmic mountain range of fire and color, with jets of light bursting from young stars like spiritual flamethrowers. You could see stars in the process of being born, something Hubble could never do in this detail. It looked less like space, and more like a dream painted by the universe itself. Exoplanets, looking for life out there. Webb also began doing something revolutionary, analyzing the atmospheres of distant exoplanets. Like a bartender checking what's in a drink, Webb can break down the chemical ingredients floating around alien worlds. One of the first major targets was WASP 96b, a giant gas planet about 1,150 light-years away. Webb detected water vapor, and not just maybe, it proved it. And that was just the warm-up. The Southern Ring Nebula, a dying star's last breath. Webb also peeped into the Southern Ring Nebula, where a dying star is shedding its outer layers like a divide butterfly leaving its cocoon. For the first time ever, we could see the binary star system inside two stars, one fading into the cosmic afterlife while its partner remains. Chapter 6. The James Webb Space Telescope is more than a camera. It's a cosmic decoder ring, peeling back layers of mystery that have surrounded the universe for billions of years. Every image, every spectrum it sends back is like a message from the past, and scientists, they're out here translating those messages like sacred texts from the gods of creation. Before Webb, we thought we had a decent idea of how galaxies formed. Little ones merged into big ones over billions of years, and stars slowly lit up over time. Webb showed us galaxies that were already well-formed just 300 to 400 million years after the Big Bang. That's way earlier than expected. It's like expecting baby pictures, but finding full-grown adults in tuxedos at the prom. That forced scientists to rethink how fast stars and galaxies evolved, and even consider that maybe the laws of physics operated differently in the early universe. Webb is messing with the timeline of creation itself. Webb is also helping scientists break down the fingerprints of alien worlds by analyzing their atmospheres. Using a technique called transit spectroscopy, it watches how starlight filters through a planet's atmosphere as it orbits, revealing what chemicals are floating around. We've already detected water vapor, carbon dioxide, methane, and traces of other molecules. What's the big deal? Well, combinations like water plus methane plus carbon dioxide could point to biological activity, especially if found on rocky, Earth-like planets. We're not saying aliens confirmed, but we're saying Webb is setting the table for that discovery. With Webb's infrared eye, scientists are detecting molecules in deep space that were previously invisible, complex carbon-based compounds floating in nebulae and around stars. These are the building blocks of life, created in the hearts of stars, then scattered across the cosmos like seeds. It's helping us understand how the universe became life-friendly, and how that life might not be limited to Earth. Webb is revealing that the universe might be more alive than we ever dreamed. We don't talk about it enough, but 95% of the universe is made of stuff we can't even see. Dark matter and dark energy. Webb might not detect them directly, but it can observe how they shape galaxies and affect the expansion of the universe. As Webb continues to map the large-scale structure of space, it might offer clues to what this mysterious invisible universe is really made of, and why it's pushing galaxies apart faster and faster. This is the type of science that could flip the physics books upside down. Webb's biggest contribution might not be what it finds, but how it changes how we think. It's showing us that time isn't a straight line. It's a layered record of ancient events still unfolding. Space isn't empty. It's alive with data, energy, and memory. We're part of something infinitely complex, and for the first time in history, we have a tool that can decode it. Chapter 7: The James Webb Space Telescope is officially a scientific marvel, no question. But underneath the press releases and jaw-dropping images lies a deeper hum, a subtle buzz of speculation. The kind of talk you won't always find in peer-reviewed journals, but it's out there, and it's getting louder. Is Webb detecting more than just light? Are we brushing up against something intelligent? The quantum chip conspiracy. One of the juiciest rumors out there is that Webb may be equipped with or connected to a quantum processor, not just to crunch numbers faster, but to potentially interface with non-classical forms of data. Translation. We're talking about the possibility that Webb might be picking up signals or anomalies that can't be explained by traditional physics. These whispers say the chip isn't public tech. It may not even be designed solely for computation, but possibly for quantum pattern recognition, detecting fluctuations in spacetime or highly encrypted information embedded in deep space signals. Wild? Yes. Impossible? Not so fast. Quantum computing is already being explored for AI, defense, and space comms. If any telescope in history would be a candidate to test that bleeding-edge tech, it's Webb. Mysterious signals in deep space. Let's talk about these cosmic whispers. Webb's detectors have picked up infrared anomalies, signals that don't match known stars, galaxies, or gas clouds. Now, NASA and other agencies usually label this kind of data as noise or unidentified infrared sources. But some theorists believe they might be encoded signals or traces of non-natural phenomena. Now, nobody's stepping up and saying aliens outright. But think about this. Webb can analyze exoplanet atmospheres in ways we've never done before. What if it found a planet with industrial-level gases? What if there's a trace of something like CFCs, chemicals we only associate with technological civilizations? That info would be highly classified before it's casually released to the public. So what we get might only be part of the full story. Rumors of the signal. There's also low-key chatter from anonymous whistleblowers, forum leaks, and even some amateur astronomers about a very specific burst picked up during one of Webb's long exposure sessions. It allegedly came from a deep field zone, lasted only a few milliseconds, and repeated once, faintly, then went silent. NASA hasn't confirmed anything like this officially, but if true, that's the kind of thing that keeps generals, physicists, and philosophers up at night. Spiritual interpretations and ancient echoes. Some believe Webb's discoveries are aligning with ancient texts and spiritual prophecies, references to golden mirrors in the heavens or lights that return from the beginning. These folks see Webb as a modern-day watcher, fulfilling roles once given to prophets and seers, except now we're doing it with machine precision. Chapter 8. Looking for life, planets, possibility, and the search beyond Earth. The James Webb Space Telescope didn't just show up to snap galaxy glam shots. It came to find life. That's one of the mission's biggest goals. Search distant worlds for biosignatures, chemical hints that life might be breathing, growing, or building out there somewhere in the cosmos. Webb is focusing its power on a specific class of exoplanets, those in the habitable zone. That's the not too hot, not too cold area around a star where liquid water could exist. Think of it as the Goldilocks zone. Perfect conditions for life as we know it. Here's what it's looking for. Oxygen, usually produced by life on Earth at least. Methane, a byproduct of biology. Cows and volcanoes alike. Carbon dioxide, CO, common, but in the right mix with methane or oxygen. Interesting. Water vapor age show. Straight up essential. Life don't thrive without it. Industrial chemicals, artificial stuff, like CFCs, could mean some bodies out there using technology. Dig targets, Earth-like worlds in focus. Webb's already been pointed at some promising systems. TRAPPIST-1, a system with 7 rocky planets, at least 3 in the habitable zone. Webb is solely checking their atmospheres for anything suspicious. Kepler 186f, LHS 114OB, K218b, all worlds that could have water, clouds, and the right temperature for life. Webb's digging deep into their chemistry. Just imagine it, a planet 100 light-years away, with clouds, oceans, and a sky colored by an alien sun. And Webb being the first set of eyes to ever see it. How would we know it's life? Here's the tricky part. Webb doesn't see little green men waiting at the camera. It sees light, split into wavelengths. Scientists analyze that light like a DJ breaking down a beat, looking for rhythm, patterns, and samples they recognize. If they find, say, oxygen and methane together in large amounts, the James Webb Space Telescope launched with enough fuel and ambition to last over 20 years, and the way it's moving, we're barely scratching the surface of what it can do. Right now, scientists are calling this the Webb era, and it's rewriting cosmic history book by book. Webb has already stunned the world by capturing galaxies from just 300 million years after the Big Bang. But scientists believe it can push even deeper, to the first 200 million years, or maybe less. That's the true birth zone of the universe, when the first stars ever ignited. Imagine seeing the moment when light itself was born. We're talking about a time so ancient, the laws of physics might have played by a different rulebook. Detect cloud layers and wind patterns. Read seasonal changes. Spot volcanoes or ocean glints on distant planets. Possibly detect biological rhythms. The rise and fall of life cycles. This ain't just theory. The next-gen AI backing up Webb's data analysis is learning fast, and the more data it processes, the smarter it gets. 3. Webb plus AI equals universal pattern recognition. NASA is already implementing machine learning algorithms that work with Webb data to spot trends humans might miss. Over time, this could evolve into systems that auto-detect possible life signals, recognize unnatural geometric structures, compare signals across galaxies to find repeating patterns. Almost like galactic Morse code. Webb is giving the machine the eyes. AI is giving it the intuition. 4. Tag team missions. Who's backing Webb up? Webb ain't out here solo forever. There are other missions coming soon to back up the Webb legacy. Nancy Grace Roman Telescope 2027 will map huge areas of the sky, finding targets for Webb to zoom in on. Think of it as the Scout ESA's aerial mission, dedicated to studying exoplanet atmospheres, giving Webb sidekicks to confirm potential biosignatures. Love War and Habak's 2030s. These two future missions are designed to go even harder than Webb, with the power to find Earth-like worlds and maybe even photograph alien continents. 5. What if Webb finds something big? What if Webb detects something that can't be ignored? A chemical signature of intelligent life, an atmospheric anomaly that's clearly engineered. NASA, the government, even global leaders would have to decide how to break that news to the public. And fam, let's keep it real, they might not tell us right away. Some believe those protocols already exist. Others think they'd leak, go viral, and shake the whole foundation of how we see ourselves. But when it happens, and it might, Webb will be the one holding the receipt. Webb is more than a telescope. It's a time machine, a reality scanner, and maybe even a spiritual mirror. Chapter 10. What it all means, spirit, science, and the human journey. The James Webb Space Telescope isn't just here to fill our heads with facts and figures. Nah, it's here to fill our souls. It's here to open up questions about existence, to break down the walls between science and spirituality, and to remind us that no matter how far we go, we're always part of something bigger. 1. The spirit of discovery. When Webb launched into the void, it didn't just carry a bunch of scientific instruments and fuel tanks. It carried human curiosity, our hopes, and a little bit of our soul. For millennia, we've looked up at the night sky and asked, what's out there? Whether it was ancient tribes staring at constellations, philosophers pondering the nature of the cosmos, or astronauts floating in space, humans have always had this deep need to know where we came from and why we're here. Webb is like the ultimate answer, a powerful tool that gives us a glimpse into the vastness of the universe that we could never imagine with just our eyes. But it's not just about facts, it's about the wonder we feel when we look at a star being born or when we think of the possibility that life might exist on another world. Discovery is a spiritual journey. It connects us all, reminds us of our shared humanity, and pushes us to go beyond what we thought was possible. 2. Expanding the mind and the spirit. Webb is changing our worldview. It's taking us from thinking of Earth as the center of the universe to realizing that we're just one small speck in an infinite expanse, and that's humbling. It makes you ask, what does it mean to be human in such a vast, mysterious universe? If life exists out there, what does that say about our role in the grand scheme? Humans have always been explorers, but Webb is showing us that our curiosity isn't just about going further, it's about growing wiser. The farther we reach, the more we realize that the journey is about understanding ourselves, our place, and our potential. We're part of a bigger story, and with Webb, we're listening to the whispers of that story as it unfolds. 3. The search for meaning. Are we alone? The most profound question Webb is tackling isn't just about the science. It's about the philosophy behind it. Are we alone in the universe? That question doesn't just challenge our knowledge of space, it challenges our understanding of what it means to be alive. If Webb finds signs of life, even microbial, on another planet, that would mean life isn't unique to Earth. It would mean that the universe is alive, thriving, and full of possibility. But if Webb finds nothing, that doesn't invalidate the search, because the question is more than just about finding life. It's about our capacity to wonder, to search for meaning, and to push the boundaries of our own existence. The fact that we're asking these questions is what matters most.